This session is for OCR FP2, topic is numerical methods, and we're looking at January 2010 question 3. So just reading through the question first of all, we've got a curve with no stationary points with equation y equals f of x. So we're told that the equation f of x equals 0 has one real root, alpha, and the Newton-Raphson method is used to find alpha. The tangent to the curve at the point x1, f of x1 meets the x-axis where x equals x2. So we can see all that on the diagram, and then three parts. First of all, we have to show that x2 equals x1 minus f of x1 over f dash of x1. Secondly, we've got to describe briefly, with the help of a sketch, how the Newton-Raphson method, using an initial approximation x equals x1, gives a sequence of approximations approaching alpha. And then in part 3 we've got to use the Newton-Raphson method with the first approximation of 1 to find a second approximation to the root of the equation x squared minus 2 sin x plus 2 equals 0. So part 1 first of all. So it is bookwork really this to establish the Newton-Raphson formula. So we're going to use this triangle to get an expression for the gradient of f of x at x1. So that means that we have f of x, the derivative of f of x at x1 will be the difference in the y coordinates, which is f of x1, over the difference in the x coordinates, which will be x2 minus x1. So all we have to do now is to rearrange that to make x2 the subject of our formula. So it will be x2 minus x1 equals minus f of x1 over the derivative of f at x1, and then add x1 onto both sides, and we get the required result. So there were 3 marks for that question, and if we just have a quick look at how the marks are awarded, you got 1 mark, a method mark for getting an expression for your gradient, and a mark for putting that equal to f dash of x1, and then you got an accuracy mark then just for rearranging it in the right form. So part 2, so in part 2 now what we're going to be looking at is we're asked to describe briefly with the aid of a sketch how the Newton-Raphson method using an initial approximation of x1 gives a sequence approaching alpha. So we go up to our curve and we draw a line, a tangent to the curve at x1, and where that point meets we were told was x2. So what I've then done is I've drawn a line up to the curve to this point, and now I'm going to draw a tangent to that point, and this now will give us, if you like, this will give us our next value. So we would call this x3. And you can see we're getting very close to the root, but what we could do is just, again, if we zoomed in, we could probably put in another tangent. So that's the sort of thing that we need to do in this question. So we're saying, basically, that the tangent at x1, f of x1, that tangent meets the x-axis at x2. So that was the bit that was described to us initially, and then we now draw another tangent from that at that point. So we draw another tangent at x2, f of x2, and then it will meet the axis, we'll call it x3. And we could go on doing that sort of thing. Now there were 2 marks for that question, and just checking on where the marks were actually recorded, basically you got 1 mark here for putting in another tangent. So again, it was just a B mark, but you needed to draw in another tangent, and then you got another B mark for describing what you're doing. So 2 marks for that. And then the last part of the question, what we're asked to do is we're asked to use the Newton-Raphson method to solve this equation: x squared minus 2 sine x plus 2 equals 0. So we have a function, f of x equals x squared minus 2 sine x plus 2, and we'll need its derivative. So we'll differentiate and we get 2x minus 2 cos x. And then we're using Newton-Raphson, which says that x2 equals x1 minus f of x1. So this is the result we had in part 1, and just need to substitute that in. So we're told that the starting value to take is x1 is equal to 1. So that means that our x2 will be equal to 1 minus, so it will be 1 plus 2, so that's going to give us 3 minus 2 sine 1 all over 2 minus 2 cos 1. And if we calculate that using our calculators, it comes to 1.598, and so on. We're asked to give our answer, well, we're not given any specific details, so in that case 1.60, we would give our answer to 3 significant figures. So again, just 2 marks for doing that, and the way the marks are awarded is just that we get 1 mark for doing the differentiation here and seeing that, and I get an accuracy mark for getting our answer correct. So don't forget that if you want to watch further revision videos, then you can access those by going to the Further Maths Support Programme website and following the link.